Hi, thanks for joining today. This is Jason with Net.Academy. We got a few things in store for you today. We're going to be covering IBGP more in depth on this one. We'll talk about how to configure it, what some of the best practices are, how to troubleshoot it. And then we're going to have a fairly lengthy discussion on the Next-Hop attribute, in particular the Next-Hop self behavior, how to override the default behavior sometimes, and when and how to use that. Okay. So hopefully you've been enjoying this. As always, if you do enjoy it, consider giving us a like and a subscribe. If you'd like to know when we have new content up, just click the notification bell. And with that being said, let's hop right in. Okay, let's hop on in. We're just going to talk real quick at a high level about IBGP. Of course, the last session we started diving in, and I mentioned that it needs to be fully meshed, or what I really said was it's designed to be fully meshed. We talked through some use cases of when you do and don't want to fully mesh IBGP. You can see that previous video, which I'll link at the end of this, in case you want to go back and review those cases. The reason it was designed that way is think about what it's meant to do. It's meant to transport routes external to the autonomous system across an internal network, right? So I have my BGP network that's self-contained unto my own autonomous system, right? And the whole point of IBGP is to take routes from outside via eBGP and transport them across the fabric of my IBGP, and probably, most likely, send them onwards to another ISP. And again, I'm not saying that you always have to run it that way. What I'm saying is that was the intent when the protocol was built. That was what they meant IBGP to be used for. What you use it for can be totally different. Like I mentioned before, IBGP might not even be needed, or it might not even be needed to be meshed at all. But I think it's important to understand the origins on these things so that when something's not working, we can add that as a tool into our troubleshooting tool belt. So this means that it was really meant to ride on the back of an IGP like OSPF or EIGRP. It's going to utilize that IP routing table to also inform its own decisions. And this is why you could have neighbors that are not even directly connected, right? I can put in a BGP neighbor statement with someone that's 10 hops away because I have IP routing table reachability to that neighbor's IP that I'm putting in when I configure it. And we're going to walk through a sample config on IBGP towards the end of this. Right. And then we also will need to look at things like having a valid route in the IP routing table to ensure that we have proper forwarding behavior. Let's dive a little deeper. So at a high level, I recommend if you're going to run IBGP, that the neighbors should probably form over the loopback IPs, not interface IPs. It'll always default to the interface IPs. But I like all my routing processes to have a router ID. I like to tie that router ID to a loopback interface. And same thing in BGP. And then in IBGP, I like to form my IBGP connections via that same loopback IP that I would use for the router ID, right? This way you have the potential for multiple paths even when you're not directly connected. That means if there's some kind of interruption in the network, you're not going to lose an IBGP peer. You'll just route around the outage, hopefully, right? Just recall that when we define an IBGP neighbor, all we're really doing is setting up a neighbor and utilizing the same remote AS value as what our ASN is, right? So if my ASN is 72,168, then the neighbor's ASN is 72,168, right? From a loop avoidance mechanism, IBGP runs split horizon. That might make kind of sense if you think about the fact that it's meant to run on top of an IGP And that's a pretty common loop avoidance mechanism in all distance vector protocols. And you're going to find that we call BGP in general a path vector protocol. And this is the vector part, right? It's going to use IBGP for loop avoidance. In fact, we'll see IBGP has a lot of similarities with an IGP, whereas EBGP much less so. And we're going to dive a little deeper into this, but we're going to want to be aware of what we call Next-Hop behavior. There's something known as BGP attributes. That's a few sessions out still. But when we get into BGP attributes, one of the ones we'll spend a lot of time talking about is the Next-Hop attribute. We're going to talk about it today, but we'll also talk about it when we go over attributes in general. There's a few really well-known attributes we want to be super aware of, and Next-Hop is one of them. Administrative distance is 200. Again, this makes a lot of sense if we just think about the fact that it's meant to run on top of an IGP, then we would not normally want a lower administrative distance than, OSPF or EIGRP or whatever. And so it sets the administrative distance quite high at 200. Hopefully that makes some sense. If not, you can always send me an email or drop a line down below in the comments. So I want to talk a little bit about Next-Hop self and the Next-Hop attribute, as I mentioned. For that, we're going to have to expand a little bit. We're going to talk about EBGP just slightly. So I have a normal IBGP network over here in AS65000. You can see it's fully meshed between R1, 2, 3, and 4, and everything looks good. It's nice and healthy. But we're going to use BGP for exactly what it was built for, which is to bring in external routes and transport them across the network. Maybe further down the stream on R2 or R4 or something like that. Perhaps I connect into AS, 789, and I'm going to pass those networks that I learn about from AS 456 to 789, for example, right? And I might learn networks from 789 that I pass along to 456. Either way, the challenge is this. The default behavior in BGP is when a prefix is coming across an EBGP link, it's going to update something called the Next-Hop attribute. And it's going to change it from whatever it was previously to the network that I share with my EBGP neighbor. In this case, it's going to change it to something on the 15.1.2.0/30 network, in particular, 15.1.2.2. It's going to say, hey, by the way, if you're trying to get to these prefixes, the 1.1.1.0 and so forth, you need to be able to get to 15.1.2.2. And the challenge there is if that's not in our IP routing table, not our BGP table, but our IP routing table, then these routers will not properly install the route. You could try and introduce these public routes in, and that's one way to do it. But an easier, more elegant way to do it is with something called Next-Hop self. This is a command we only put on routers that speak both IBGP and EBGP. In this diagram, there'd be no point in putting a Next-Hop self command on R2, 3, or 4. But since R1 has both E and IBGP, it makes a lot of sense. And what it does is it overrides that default behavior. And instead of the Next-Hop attribute being updated to 15.1.2.2, it instead updates it to whatever the loopback 0 interface IP is on R1. I don't know, let's call it 10.1.1.1 or something. And that is, of course, in our IP routing table. And therefore, our 2, 3, and 4 will properly install and forward the route. Hopefully that makes sense. I know we went a little bit deeper there, but if you have any questions, just let us know below. Real quick, a look at how we might configure IBGP in general. We just start our routing process with router BGP and you assign it an ASN. You give that router process a router ID. I would always tie it to a loopback interface, in my case, loopback 0. And then I'm going to set up my neighbors, right? And if I'm fully meshing, again, not always required, but if you are fully meshing, then you're going to do um, these next two commands per neighbor you're going to mesh with, right? You're going to define the neighbor first, BGP neighbor, give the loopback 0 address of that neighbor, and then the remote AS, and it should have the same ASN as the ASN that I'm configured for. And then I can also likewise do BGP neighbor, and again, the neighbor's loopback 0 IP address, update source, and my loopback 0 address. What this does is it changes the source IP on general BGP updates to be sourced from my loopback, which is always going to be reachable from the IGP typically, right? So the question of how will you route to these loopbacks? The answer is via your IGP. Hopefully that makes sense. Okay, I want to end today's session with a little bit of troubleshooting, right? So if you are configuring BGP, IBGP in this case, but really it applies to either, and your neighbor is not becoming established, right? The neighbor just doesn't come up. A couple of things you can check. What's your update source? Did you change it to loopback 0? If you did it on one end and not the other, or if you didn't put a loopback or something in the IGP table, this could be a problem, right? You need to make sure you have IP table reachability for those update source IPs. Likewise, remember that BGP is a reliable routing protocol. Ensure that you're not blocking TCP 179 between two neighbors, right? If you have an ACL or firewall or something like that, ensure that you're allowing TCP 179 to get through. And if your neighbor is up, but a route is not installing, look at that Next-Hop attribute and possibly consider utilizing Next-Hop self. Okay. I want to reiterate that although it wouldn't hurt anything, you don't gain any benefit and possibly cause confusion if you configure Next-Hop self on every IBGP speaker, right? It really only needs to go on a router that is bringing in eBGP routes and it's running IBGP as well. If it's doing those two things, I would consider using Next-Hop self so that that Next-Hop attribute moves off of the eBGP network and onto the IBGP network, which will always be installed in the IGP. Hopefully all that made sense and you got some good value there. I think next session we'll go through and do a short, brief lab on IBGP. And then after that, we'll dive into eBGP. And then we'll do a lab where we integrate the two together, which will be a lot more fun. Thanks, everyone. We always appreciate it in Net.Academy, you taking the time to stay with us and learn with us. Remember, our goal is always training for engineers by engineers, and hopefully you're getting something out of this. Have a great day.